Good evening, Miss.
Okay, dear. Good evening. Yeah. So we have the other part of electrolysis today, right? We discussed electrolysis main area, right? That was the actual electrolysis. That means breaking down of the chemicals. Now that we divided the electrolysis under two categories, right? What was the first one? I said depending on the electrodes, you can divide it under two categories. Electrodes can be reactive electrodes and unreactive electrodes, right? So first one we discussed was unreactive electrodes. That means inert electrodes, right? And now we're going to take the reactive electrodes. That means when the electrode, right, can react, what happens to the solution, and we'll see what happens to the things, right? Okay, are you okay with that? You remember the electrolysis with inert electrodes, right? That means carbon or graphite electrodes, right? We did that. Now we're going to see the electrolysis with reactive electrodes, like the metals. That means, right? Just take example like this. Right, I said electrolysis can be categorized under mainly that. Electrolysis can be broken down under two areas. That's inert electrodes, right? And reactive electrodes, right? Inert means unreactive, right? Reactive electrodes.
Yeah.
So under that also we learn inert reactive electrodes. We can take now consider the electrolyte, right? With the inert electrode. But if we take molten electrolyte, right? Molten electrolyte. Then the other one was aqueous, right? Okay. Under aqueous electrolyte also we had two electrolytes, right? We can take aqueous electrolyte also under two categories. What are they? Because I have no space here, I'll just write here. Dilute and concentrated, right? Okay. Two categories, right? So you should be able to write for these ones, you should be able to write the products, mainly the products and the reactions, right? You know, in this one, we don't have a competition, but when it comes to this one, the ions have competition, right? There were several mnemonics that can help you, right? There were songs, not songs, there was a mnemonic like that. So then here also we had to choose the ions that go to the respective electrodes, right? Carefully. Now, when it comes to reactive electrodes, the story changes completely. Why? The metal can react now, right? So what happens is the solution doesn't have to provide all ions. In the previous case, remember, always the solution or the electrolyte. It can be, I'm just using the word, common word solution, but it can't be the word solution. We have to say it's an electrolyte, right? Always the electrolyte had to provide the ions, remember, in these two cases, because the electrode was not providing electrons, right, to the battery. Battery was asking for electrons, battery was giving out electrons. Remember the battery story, right? So molten electrolyte and aqueous electrolyte provided the ions so that the problem of electrons can be solved, right? The electron transfer or electron circuit, the electron flow can be maintained. But when the reactive electrodes are there, The solution doesn't have to do it all by itself. That means sometimes the electrodes itself can give out electrons, right? Or electrodes sometimes take in electrons, right? So we see what happens there. In this case, we have two categories again. We studied this under your syllabus. We studied this with under two categories. One is refining. One is refining the metal. The other one is electroplating. Electroplating. That's the breakdown of the story, right? The whole story. So actually, both of these have the similar reaction. So this is very much similar. This is very easy to understand if you just remember them as one category, right? That's quite like the same reactions. Similar reactions happen here. Okay, refining, and I usually tell a small mnemonic for this side. The small mnemonic, okay, to remember it. Cat is getting fatter. Or cat gets
I
fatter.
can't hear you.
Ah, sorry.
Miss, should I rejoin? I can't.
Ah, yeah, you are very
Can
softly speaking. You can't. Oh, is it so? Can you join again then? Okay. You join again. I'll be keeping this, right?
Miss, the screen also was like stuck. Now, yeah, Miss, I'll join again. Okay, Miss.
Oh, yes, yes. Yes, join again. I think the screen, I'm sharing the screen here. Yes. Maya? Okay.
Oh, yeah, Miss. Now,
Right.
Miss, I didn't hear you from the part you started explaining the reactive electrodes, like the refining.
Yeah. So, can you see the screen there?
Yeah, I can see.
Oh, okay.
No, before the screen also was not
Ah,
appearing.
you can see the screen, right?
Yeah, yeah, I can see.
Okay, right. So I was talking about this. I was telling in this reactive electrode side, the refining and electroplating, both have similar, similar reaction. So very much similar. Okay, like if you study one of them, the other one is like the same thing. You will get it easily, right? So that's kind of easy to understand. Like as one thing you can study, like one whole thing, right? So the point is this, for this area, I will just tell a small mnemonic to remember as well. The mnemonic, a small mnemonic, okay, very small one. There I tell the children, you should, I don't know whether other teachers do this, I just made it up. Cat is getting fatter. You know, cat gets fatter, right? Sometimes.
Yeah.
Okay, cats. Okay. gets better. Just think that one. That will help you to get the idea which side is getting coated. Now you get the idea? Which one is getting coated? That means the which side is getting coated by a metal, or which side is getting heavy. Which side is, or which electrode is getting coated? Cathode or anode?
Cathode.
It's cathode, right? That's what. So remember this sentence, then you will remember always it's the cathode, right? You will never forget that. That's anode. Anode never gets actually coated, right? Only cathode. So that's cat, right? Cat story, right? Let's take this one now. We're going to see one by one, right? One is refining, okay, and then electroplating, and then it's actually done. And you can go to the cells and the simple cell, and then you can, if you want, you can go for some other area of electrolysis, or else you can go for paper. You can do papers, okay? Right. Let's see. First one, refining. So what's the meaning of refining? Refining is making a paper, or tell in other terms, if you tell it in other terms, it's called purification of a metal, right? Purification of a metal. Okay?
Okay.
We're going to make a pure, like impure metal,
Yeah.
a pure one, right? So just think, when we unearth metal, darling, sometimes when we even go through some chemical reactions even and try to get the metal pure, still sometimes that metal is, metal molten liquid is there, right? Molten metal liquid, but sometimes it's not pure completely. It has some impurity, right? Like just think, you have made the metal, but that metal, solid metal, is not a pure metal, right? So then if you want to make it a pure one, what should you do? So what should you do? Like, which side is getting fatter? Which electrode is getting fatter?
Cathode.
Cathode. So if I place my battery like this, to which side or which electrode should I place the one that should get coated? The metal that should get coated should be placed on the
Cathode.
cathode, yeah. So usually our pure metal, or that means we start with a pure thin rod of metal on the cathode, so that we can get it coated, right, with the pure metal. That means whatever something comes on and gets coated will get coated on the cathode, right? So we need to get this side fatter, right? The fatter side. So the one that the side that we want to get coated is the one that you have to have pure metal. That means we start that also with a pure rod, right? A pure metal rod, so that we have the complete thing made of pure metal, right? Because we have to start with a small, because of that, we have to start with a pure small rod of metal. And then we can have the impure metal. It's like dirty metal. I will show like this. Some parts are there, right? Okay. Now this is dirty, okay? Some stuff like this. Okay. Now that's placed on the anode. Okay. Right. Let's take now let's take the solution. Right? Isn't it? We need a solution, no? What kind of a solution do we need? Okay, take this case, like this is copper metal. If this metal is copper, this is impure copper, and this is pure metal copper, right? We want to get this side coated. So this is a copper sulfate solution. Okay, right. We have to have this line should be greater here. Oh, wow. Onto that. Okay, right. Now my this is my copper sulfate solution. Okay, and I have to name this one. What is this one? Impure. Yeah, it needs to be here. Impure, right? Impure copper metal. This is pure. Pure copper metal. First of all, understand that fact. Are you okay with that? This is the reactive electrodes story. Story of reactive electrodes, right? And these are reactive electrodes. So what happens? Now start with the story like this. Reactive electrode number 1 is refined. Yes?
Electrolyte is what? What is the electrolyte for this?
That's what I'm asking. Okay, what kind of electrolyte should we need? Yeah. Tell, what do you need? What kind of electrolyte do we need here? What should be the
It's
solution?
like something that doesn't react much.
No. We need a
Something that
solution
doesn't
too.
react.
Oh, no. No, you don't have to go for that. Reaction means like there should be a solution which is actually going to be containing ions, right? There should be ions. Yes, the electrolyte
Okay.
reacts too. You will see, because the reason is that like, both side electrodes are not going to react in the same way. So you need some involvement from the electrolyte too. You will see that. The electrolyte also actually
Okay.
takes place in reaction. You like see what's happening, right? When you like if one side is actually getting in one side the metal is getting actually, yes, metal is going to lose and metal is going to pour, that happens, but this electrolyte also has some involvement. Let's see what's happening inside, right? The solution actually should contain the same metal as the base, right? This electrolyte has a requirement. What is it? It should contain the metal that is here. This metal ion should be there, right? Okay, if you want to coat some metal, we need to have that metal in the ions too. Solution in the ionic form, like copper sulfate. Okay, right? Okay, this is a solution. Now let's start the story and see
Yeah.
what happens. Okay, we started the battery on, or we switch the battery on. What happens? Now what will happen? Same story of the battery. Battery does the same thing. What is the what does the battery do? You know the story of battery. Batteries, one side is doing one thing, the other side is doing the opposite thing. What is that?
The electrons are flowing,
From one side.
and
Which side?
then other side
From which side? From which side, darling? Side of the atom.
from the from this battery cell to the cathode.
Okay, you
The
can tell
electrons are flowing,
the negative
and then
terminal of the battery. Okay, negative terminal of the battery contains electrons,
yeah,
right? Okay, so this is the negative
yeah,
terminal, the short line, right? It sends electrons downward. Okay, right. We have some extra electrons then on this sheet, right? Okay, okay. It
yeah.
contains electrons. Now the cathode gets electrons. And what happens at the anode side? There is a pull.
Here it's attracting
Yeah,
electrons,
it's attracting or pulling or asking for electrons, right? Now the
pulling.
story, yes, pulling
Yeah,
the electrons. So what happens is the star at the beginning, just give me a second. Okay, right. What happens is this, when the battery is like pulling from the other one side, yeah, what happens? The two metals now out of the story, yeah, which like this side, the metal anode has to do something. What is it? Now, earlier in our electrolysis, what happened was the ions in the electrolyte got attracted, isn't it? Right? Ions got attracted. Now, remember
yeah,
that story? In that case, an ion got attracted here, right? Remember? But now what happens is the metal is reactive. We learned the point, right? This is the point. Important point is the metal, the electrode is reactive. So what does the electrode do? Or the metal do? It doesn't let the anions come here. It says, okay, I will handle this problem. The battery is asking for electrons. You understand? Take this like story and then you understand, right? The battery is asking for electrons from the positive terminal. And the anode electrode says, okay, says to the solution, don't worry, I'll handle the solution. Like, I'll handle this problem. I'll give electrons. How does it give electrons? How does the metal copper give electrons to the battery's terminal? Like, it has to send some batteries to this positive terminal because it is asking for electrons, right? So what does this terminal do? This is copper, no? Right? How can they
it
provide electrons?
reacts with the
Yeah.
solution.
Yeah. What does it become? What does it become? You can say like this, the metal, no? This is copper metal, right? What's in this solution? Copper metal. Okay, I'm going to use this part because to keep that clean. Now copper metal in this copper, this is copper metal, right? And that enters the solution becoming what? Copper ions. Okay, and when that happens, when copper metals become copper ions, what happens? It can give out electrons, right? That's the thing. Oxidizing. Copper atoms become copper 2 plus ions. That means oxidizing now. So it loses electrons, right? 2 electrons in the process. So those 2 electrons can be given to the battery now, right? We have 2 electrons left, right? Now that 2 electrons can go through this side, isn't it? Right? Electrons are not jumping in the pool, okay? Do you get that point? Right. Get the point like that, okay? The electrons are left on the left. It's like this. The fellow says, okay, I'll remove my cap on my plate and I'll jump to the pool. Right? It's like this. The battery is asking for caps or hats. Taking that case, like it's like passing of hats, right? Hat passing case. Okay. Battery is asking for hats. Battery's positive side is asking for hats. And this side, there are people who are wearing hats. Okay, just the metal atoms are there. So they have the hats, and then the metal atom says, okay, I'll give the hat to you and I'll jump into the pool. Usually you jump to the pool, leaving the hats, right? Do you jump to the pool with the hats on? No, right? So the electrons actually left there. Electrons are left on the metal electrode, right? And these electrons go towards the positive terminal, can go, right? The problem solved. That side problem will be solved. So always copper ion has to jump to the pool, right? Jump to the pool, becoming copper 2 plus ions. Okay, now they don't have the hats. Okay, let's try the reaction. What's the reaction? So let's write it here, guys. Yeah.
How do we know it loses two? How do we know that it loses two?
Oh, that point is like copper's metal ion. Like what is the stable ion that copper can make? That comes from your the ion identification, ion nature. Sorry, ions oxidation numbers. You learn it under ions, right? You can learn it under ionic numbers. You might be learning under oxidation numberlism, right? Copper is a transition metal now, so we have to memorize it. Actually, in that case, copper can form 2 ions. It can form a +1 ion and +2 ion. At this level, you're not learning how it happens because you're in all of us. So you can just memorize the ion. Copper 2 plus is common dal. Copper sulfate also contains copper 2 plus.
Oh, okay.
Isn't it? Copper is a 2 plus ion, common ion. And there's copper 1 plus also. This is copper 2 plus ion we talk about. So mainly this copper 1, copper atoms form copper 2 plus then. That's oxidizing, isn't it? Right? Copper 2 plus and become what? Or leave the electrons. Right? Now that electrons are lost, so that we get what? An oxidation reaction. That's what happens at the anode. Okay?
Yeah.
Okay. Now the other side, what happens then? On the other side, we have electrons, negative side. Now what happens at the negative side then? What do you think will be attracted? In the solution also we have copper ions and hydrogen ions. Which ones will go there? Which ones will go there?
Copper 2 plus ions?
Yeah, copper 2 plus ions go there and get what? Electrons and select the electrons and
and then they give it back to the.
Okay, first tell me what do they become when they get the electrons like that? They go there and yes, get the electron and
Do they like go back and then give back the electrons to the other side?
it is not giving the electrons back again. Yeah, it's not giving the electrons. It's a copper 2 plus ion. How can it give the electrons, darling? It's a positive ion. They can't give electrons, they can gain electrons.
Yeah.
This one is gaining electrons, right? This copper 2 plus is gain electron and become what? Copper metal. And coat on top of this. What is happening here?
Okay.
It becomes the copper metal and coat it. Coating, right? Yeah. Let's write the reaction for that. Okay. I'm just writing here copper. Sorry, I had write the reaction here. I can erase it. Okay. It is pure copper. And then let's try the reaction. What happens is the same reaction opposite, but that's easy to memorize actually. Look at this, right? Copper 2 plus ions, okay, gain 2 electrons from the electrode, right? And coat it as what? So form copper metal atoms. This is copper metal, okay? Now copper metal atom can coat on the electrode. So that's why we say cat is getting fatter. This one. Get the idea? cat gets better.
Yeah.
Cathode is getting coated. Okay, so it's getting coated. We call coated with copper atoms. Now, what happens is because of that, electron like continuously electrons can be sent from the battery. The battery is sending electrons to electrons. So you get more copper atom, more copper ions coming and collecting those electrons and depositing there, right? It's getting deposited there. So then continuously deposit like that. Okay, and we get the cat fatter. Right? Cathode is getting fatter. But the reactions are easy to remember, anyway, isn't it? Same reaction, opposite. Look at this, copper metal atoms. On the impure side, metal atoms become copper ions and it dissolves. That means it enters solution, right? Metal atoms become ions and enter the solution and losing the electrons. That was copper, become copper 2 plus and lost 2 electrons. Okay? And the other side, what happens is solution. From the solution, those copper ions can go and collect the electrons, see copper ions, copper 2 plus ions, gain electrons and become copper metal and coat on the cathode. Okay? Okay? Okay or
Yes.
not? We have problems there, huh? Right. Then what happens? What can
Yeah,
you
miss.
see? What can you see? So what are the observations that you can make about the anode and cathode then? What happens at the anode and what happens at the cathode?
Oxidation
Oh
and
yeah,
reduction
but you
at
can't see
cathode.
that you can't see. You have to see. Tell me the observation that you make.
Okay.
What can you see?
The pure
Mm-hmm.
copper gets coated,
Mm-hmm.
and then
Where? My God. Tell me where exactly.
the pure copper at the cathode gets
Yeah.
coated.
Okay. What's the color of copper? What's the color of copper metal?
Reddish brown.
Yeah. No. The metal is like pinkish. It's a nice
Orange
pink.
brown.
It's orangish
Oh,
brown
okay.
later on. Later on, darling, it's a pink metal, or you can say brown,
Oh,
orange, but brown later on. Yeah. If you get a lot of pink metal for it, you can see the brown. Okay. Yeah. So the anode, what happens anode?
at the anode, the impure copper
Hmm?
becomes copper 2 plus ion once it
Okay. Now don't write that. I'm asking the
enters the
observation.
solution.
I'm asking the observation now,
Oh,
not the
oxidation.
reaction,
Okay.
not the explanation. The observation.
Okay. Like if it like produces anything, like a gas,
What
anything.
happens? You can see now what's happening here. You see this, like this will do something to the electrode. No gas is forming. Just what you see here. This reaction. This particular reaction only happens. So what happens because of this reaction? I'm asking. What happens because of this reaction?
Will it become pure and
Not pure. It's not pure becoming pure. It's degenerating, darling.
is
What
it
happens?
the appearance?
Yeah, the appearance changes. Why? The appearance actually changes because this get what? It gets decay, darling, with the time,
Oh, okay.
isn't it? It changes the shape, no? It's dissolving. Okay? The metal dissolves here.
Yeah.
So it gets decay, or you can say it get decomposed, right? It's completely going to degenerate. We use the word degenerate there, right? Anode. And the cathode is getting fatter. That's what happens, right? One guy is getting degenerated, the other guy is getting fatter. And the remaining dirty stuff, like the dirt, the impurities, where would you see them? They will be forming on the bottom.
On the bottom?
Yeah, they will form on the bottom, yeah, like this. I'm using the eraser. I'm using eraser here. Yeah. You see the you see the impurities on the bottom. Okay, right. So yeah, this is what happens. Again, tell now. How do you start the story? What should you remember in refining? How do you explain the story? What happens the color of the solution? I forgot to ask about that observation. There are three observations you have to make. One is what happens at the cathode. right? When you are supposed to tell the observations in electrolysis, darling, you have to tell the observations. Okay, that means what you see. Okay, at the anode, at the cathode, and at the solution. So tell the colors, like what happens the color of the solution. What happens to the color of the solution?
It changes color.
It changes the color. What do you think? Will it change the color? Think technically and tell. Will it change the color? Or will it not? You see here, copper ions are going from here, right? The copper ions that we had in the solution are going and coating on the copper cathode. That's right, on the copper cathode is here, right? But can you see on the other side, the anode is degenerating and providing copper ions? Can you see that?
Yeah.
Can you see it's equal? When one copper atom goes, you get one copper ion, right? And 2 electrons are lost. Same applies here. When one copper ion collects 2 electrons from the anode, from the cathode, it forms a one copper atom. So is there a difference here? No, right? There's no change
No.
happening. So the color is, what will happen to the color? The loss of copper ions are replaced by copper ions, darling. That means, yeah, we are losing copper ions from the solution, but we are getting copper ions also from the solution. Do you understand the point? These are going and coating, yes, but these are coming into the solution in the meantime. So what does that make? The color doesn't change. Copper sulfate is blue in color,
The color
right?
doesn't change.
Yeah, so copper sulfate, the blue color, doesn't fade away in this case. Okay, right. In the case of electrolysis, normal electrolysis with carbon electrodes, the color fades, yes, in copper sulfate. Okay, here doesn't change.
Miss, this
Even
is
this,
for like, it doesn't change for every type of reaction
yeah, for all
in
the like,
refining?
yeah, in refining it doesn't change. Unless they
Okay.
mix
For
up
every
and give,
solution.
right? Yeah, like if it's the same metal, if it's the same metal that you have in the electrode stuff, check that also. Same metal should be there in the electrodes also, right? If the electrodes also are made of the same solution, same metal like this electrolyte contains iron, right? Then that will be replaced. There won't be like there won't be any difference in the color. But the thing is this now, darling, like in the case of like silver nitrate and all, like we take silver solutions, gold solutions, sometimes they are colorless. They're not colorless, they're not colored solutions like copper sulfate. Because of that, we don't see a color change anyway, right? We can't see a color change anyways, right? Technically, it's just white and you can't see anything happen. Like it's just white, colorless, you see nothing happening, right? That's why. So same thing happens with silver and other ones, right? So that's the story of electrolysis. Okay. So only one type of reaction you have to memorize, isn't it? Now remember, I can ask questions now. Can I?
Yeah.
Okay. Let's sit then. And let's take a table and refining. Okay. What if I have right? I want what happens at the anode and cathode with the reactions. Okay. If I use electrolyte, my electrolyte is silver nitrate. Get this carefully and tell now, silver nitrate. And my electrodes are made of silver electrodes. What will happen?
Miss, both the electrodes are made out of silver, right?
Yeah. Both are silver.
Okay.
Yes.
Miss, for silver, how many ions do they lose?
What do you mean by how many ions means?
Like for copper, it's like 2 plus. Like for
Silver,
silver,
silver versus iron. Yeah, do you know how to do this backward crisscross, darling? It seems like you're lacking in some of that basic stuff. This is the compound
okay,
I gave,
so
right?
it will be
Yeah, I
plus
gave a
3.
no. That's the case. You have a problem with ionic numbers, it seems. Um, Tell me, like, I'll remind you that area if you want ionic table, like help, right? Ionic number or help with the table, darling. This is nitrate ion. This is a nitrate
Yeah,
ion. Nitrate ion is actually NO3 minus. The ion is NO3. Ion contains 3 oxygen atoms. Okay, NO3 means there are 3 oxygen atoms in that. This is ion, nitrate. NO3 minus. So this -1 and silver should be what then? Silver should have been +1, right? If this -1 and +1, that's why we get cancelled here, no? That's why our final answer, crystals. You get this one, right? That's why you get this one here. I mean, with this bracket, we put the bracket and you get 1 here. You know this, right? This is 1 here.
yeah.
So you get the ones, and anyway, you can cancel the ones because it's just multiplied by 1, right? Both are 1. Can you see that? That's why we get, oh wow. That's why we get silver nitrate like this. So that means we can do the backward crisscross and get what? You do the backward crisscross here. When you have a compound like this, do the backward color, right? This is nitrate ion. You have to identify that, right? NO3 is 1 ion. So you should know that. You should memorize that. Nitrate is a -1 ion. If this is a -1 ion, what should be the silver's ion here? The +1 ion, right? That's because they have to be cancelled, no? These are the 2 ions.
Yeah.
Okay, right. First take the ions like that, and then you can now, okay, you count ion now. You have the silver ions, right? Silver is a +1 ion, darling. Always silver forms +1, nothing else.
Oh,
So now
okay.
take that one. I mean, silver cannot form any other ion. Like, even though it is a transition metal, it forms only +1 ion. Now take that and tell. Okay.
And Miss, the electrolyte solution, do I take it as anything or is there a
Yeah,
specific?
the solution is given here. That's the solution is given. Silver nitrate.
Ah, okay.
That is the solution. Okay. Meanwhile, so hurry up.
So at the
Next.
anode,
Yeah.
silver +1 ions are formed with the
Not anode.
solution.
Anode is not forming, no. Silver ions are forming. Okay. Silver ions are forming from what, darling? Silver metal. They have tell that.
From
Silver
the
metal
anode,
becomes.
silver.
Okay. Silver metal becomes. Tell it properly. Start from the correct statement.
The silver
Silver
metal
atoms.
becomes
Mm, silver.
+1 ions.
Okay. And and
+1 silver ion.
and 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 what is lost?
And it loses 2 electrons. It
Two
loses 1
electron.
electron.
One electron. Electron. I'm writing electron with this -1, right? Okay. That's electron. Okay. Then at the
Yeah,
cathode. That's it. That's correct. That's oxidation. Right? It's oxidation of silver atom
yeah.
became silver plus an electron. Right? What's happening at the cathode?
At the cathode, the
Mm-hmm.
silver ion
Yeah.
coats the cathode
Mm-hmm. Okay. Get
and
what?
it
Okay.
gains
Mm-hmm.
1 electron
Mm-hmm.
to become silver um,
Silver atoms. Or you can say silver
a
metal.
silver solid, silver
Yeah.
atom.
Okay, silver atom. Silver atom. When you say, darling, the meaning is that we know silver atom means it's a solid, right? Okay, here we have the aqueous. Okay.
Yeah,
And this was metal atom, right? That was the metal atom became silver ions. On the other side, silver ions became atoms. Yeah, opposite happens, right? Isn't it? Yeah, the
yeah,
opposite happens. So who gets fatter? You can remember like this. From the cat, you can remember the story. Remember, cat is getting
yeah.
fatter. That's the point I told you. That. Okay.
Yeah.